Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is find all anagrams in a string. Very simple problem. We'll be given two strings S and P. We need to return array of all the start indexes of P's anagrams in S. P's anagram in S. So what is an anagram? Let's see that. Anagram is a word formed by rearranging the letters of a different word. For example, let's say we have string ABC. We have string ABC. So anagram of this string will be BAC. That is, we are rearranging the letters of this string. A is there, A is there, B is there, B is there, C is there, C is there. Just what we are doing, we are just rearranging the letters of this string. For example, CAB. This is also an anagram of this. CBA. This is also an anagram of this. Right? So what we need to do in this problem, we need to find all the anagrams of this ABC in this string. So anagrams of this ABC will be what? BAC, CBA, CAB, all these will be anagrams. So if you see, this is one anagram of this ABC. This is one anagram of this ABC. So CBA is an anagram of this, BAC is an anagram of this. So if you do indexing 0, 1, 2, 3, 4, 5, 6, 7, 8. So what are the start indexes of anagrams? For this anagram, start index is what? 0. For this anagram, what is the start index? It's 6. So this will be our output. We need to return, what we need to do is we need to return array of all the start indexes of P's anagram in S. So P's anagram in S are there are two anagrams and their starting indexes are 0 and 6. Right. I hope you understood the problem. Let's see now how we will approach it. So see, over here we have to find all the anagrams of this pattern, right? If you notice one thing, what is the difference between a string and its anagram? For example, this is our original string ABC and this is the anagram BAC. What is the difference between these two? See, only difference is that they are rearranged. They are rearranged. This is rearranged version of this one. There is no other difference, na? Letters are same. B is there, B is there. A is there, A is there. C is there, C is there. For example, if we take some another string, let's say we have AA, B, C. So anagram of this will be what? Anagram of this will be A, B, A, C, let's say. So here, there are two A's, we have two A's. Then there is one B, we have one B. There is one C, we have one C. Just that these are arranged. These are rearranged. Rearranged. Do you think this will be anagram? Let's say over here, this will be anagram AA and we have CD. So will this be anagram of this? No. Why? Because we have two A's, okay. We have C, but here it's B and here we do not have B. Here we have D. So letters are not same. Letters are not same, hence there are not anagrams. For anagrams, all the letters should be same and their count also should be same. Their count should also be same. For example, if we take this A, let's say CD, this is the string and its anagram, will this be anagram of this? No, it will not be. Why? Because CD is there, okay, CD is there. Here there are two A's and here there is only one A. We have to have two A's. So if we have, let's say we have this AC, AD. So this will be anagram of this. These will be anagrams. Why? Because there are two A's and there are two A's. Then C1, then D1. So I hope you understood what we are trying to think over here. Anagram, two strings. two strings will be anagram when two strings will be anagram when all the letters are same in both the strings. All letters are same. That is, if B is there, B should also be there. A is there, A should also be there. C is there, C should also be there. Secondly, count also should be same. Count of letters should also be same. Count of each letter. You can say each letter should also be same. Should also be same. That is, for example, if here we have A, B, C. So here in the anagram, we should have two A's. We should have two A's because here we had two A's. Here we have two A's. This will not be valid if we have one A. If we have one A, here we require two A's, but here we just have one A. So this will not be valid. Right? So let's see now. I hope you understood this point. Now try to think how you can find all the anagrams. Like this is the string. How you can find all the anagrams of this string in this. Like one is this anagram and other is this one. How you will be able to find this? Just pause the video and think. See guys, what we will do. What we will do is, we need to know what letters are there in this pattern. What letters are there in this pattern and how many are there. Right? We need to know that. So let's do one thing. Either what we can do is, one thing we can do is, we can make all the we can just find all the substrings of this string. All the substrings we can find. Like all these will be the substring CB, then CBA, like this, then CBAE. All these will be substrings. We can generate all the substrings and then we can check whether this is an anagram of this or not. That is, we can just check each letter, whether each letters are same and their counts are also same. That thing we can do. But that will not be an optimized approach. Why? Because we are generating all the substrings. So that will be something like square or some like like n cube it might be. So that is not optimized approach. Right? Other thing which we can do is, see, we know what we can do is, see, we have to find anagram of this pattern. So anagram will also be of what? Same length. Obviously, if there are three letters here, so the anagram will also have these letters only, these many letters, C, B, A, like this. This is your string, this is your anagram. So see, this is a window. This is a window. What we have to find is, every time we have to find whether there is a window of this much size, here, whether there is a window, and whether that window has all the letters which are there in this pattern. All the letters are there, all the letters are same, and count also should be same of each letter. So here what we can use the approach sliding window approach. Sliding window. And in that sliding window also, what we have is, in the sliding window also we have fixed sliding window. We have fixed sliding window. Why fixed? What fixed means? Means the size of the window is fixed. Always the window size will be size of this pattern. Because this will be the size of the anagram which we need to find. So this is fixed sliding window. So how we will approach it? First of all, what we will do, we need to know how many and what all letters are there in this pattern. Right? So for that, what we can do is, either we can use a map and we can store all these letters in the map and their count respectively. Or we can do is, we can have an array. See, these all are letters. These all are letters, right? So we can have an array of size 26 and we can store these letters in that vector or array. So that is also we can do. We can use a map also. So it totally depends on you what you like to take. You can use a array or vector to do that. So let's do one thing. Let's take a vector. So what we will do is, we will have this vector. Let's say this will be our pattern. Let's name it as pattern frequency. It will tell us what all the letters are there in this pattern and how many of each letter is there. So this will be of size 26. This will be of size 26. 0, 1, 2, 3 up till this will be 25. And each over here will represent a letter, like 0 index will represent A, 1 index will represent B, 2 index will represent C, like that. So what we can do is we can store this count over here. So A is 1 we will store at 0 index, we'll store 1. B is also 1, so we will store here 1. C is also 1, so we'll store at index 2 1. For example, over here there is another C. So then the count of C will become here 2. Here we are storing the count of each letter. But over here we are not taking another C, we just have only single C. So here count will be 1. Here we are in this vector, we are storing the count of each letter. So here what we did, we have stored the this pattern in this array. Now let's do the sliding window. Let's start the sliding window. So in sliding window what we do is, let's see, we need to see when we will be starting our window from this. This will be our first window of size what? Size 3. This is the first window. Now we need to check whether all these letters which are there in this window, are they same as this pattern? If they are same, that all the letters are same, like here CBA, here ABC, these letters are same. So this is an anagram. These are anagrams. This is CBA is an anagram of ABC. So we need to store this also somewhere, that what all these letters are. So for that also what we will make, we'll take a vector. You can use a map also. And this will be, let's say, our string, or you can say this is our window. This will store our current window's letters, whatever letters are there in our current window. This store letters of our window, right? So what we will do is, this is our frequency of pattern, like pattern, whatever letters are there in pattern, this will store that. So this will also be of size 26 because there are 26 letters to 25. And current window has what? C. So here 1 will come, there is only 1 B, so 1 B's we store here, and A will come here. 0 is A, 1 is B, 2 is C, and so on. 25 is Z. This is a Z. So this we have seen. Now we will see. So if you see, these two vectors are same. These two vectors are same, means these are anagrams of each other, because all the letters are same and their count are also same. So this is an anagram. So what we will do is we will store the starting index. What is the starting index? Starting index what? Let's do indexing. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So starting index of this is 0. So 0 will store here. Right. Now this was our first window. Now this we will initially check. Now let's start our sliding window. So we will take I here at index 3. And what will be our next window? Our next window will be BAE. BAE will be our next window. CBA was the first window. Then BAE will be the second window. Right? Then AEB will be the fourth window. Then EBA, like this it will go. Right? So if you see what happens. Over here, this was the first window. Right? This was the first window. Now the second window will be BAE. This will be the second window. So in the second window, what we did? This character was removed and this character was added. Right? This character was removed and this character was added. So accordingly also we have to change this window array here. So when we will shift our window, this C will get removed. So C will now become 0. We will remove C. Like C's count will decrease. And we are adding E in our window. This is our window. We are adding E. So E is stored at what? E is stored at 4 index. This is 3 is your D and 4 index is your E. So E's count will increase. It will become 1. C will become 0. So in this way, we are storing our window. This is our window. We are storing it in this array. So if this is our array C, B, A, E, B, A, B, A, C, D. How window is moving? First of all, this was your initial window. Then we have to shift this window. So what will happen? This character will go and window will start from this second letter and it will go to the this, because windows will be of size 3, because the pattern is size 3. So in this way you will be shifting your window. That is, this character will go and this character will be added. Similarly, now what will happen? Next window. So these are not, now see, these are not same. Here one is there at 4 index, but here there is not. So these are not same, hence they are not anagrams. BAE and ABC are not anagrams. We'll shift our window again. So window will be shifted, B will go and this will be added. That is, now window will become AEB. See, one index forward and from back one index is like reduce. It goes forward. So now what will happen? This B will go, this B will go. So B will become 0 and this B is added. So again B becomes 1. Now AEB, these are again not same. Hence we will again shift our window. So now window will become what? Window will become, currently window is AEB. Now window will be EBA. EBA. So that is this A. Earlier window was AEB na, so A will go, A's count will become 0 and this A will be added. So this A will be again make it 1. So this EBA will be the new window now. Now see this is also not same. Hence what we'll do is we'll again go to the next window. So next window will be what? Currently window is EBA. Next window will be BAB. Like this E will go and this B will be added. So E will become 0 now and B will become 2 now. Because this in this window BAB, there are 2 B's and there is 1 A. So 2 B's, 1 A. These are also not same. So again we'll shift our window. We'll come at ABA. Hence this B will go and this A will be added. So B will become 1 now. B will become 1 now and A will become 2 now. So current window is ABA. Current window is ABA. 2 A's, 1 B. This is also not same. So again we'll shift our window. Currently window is ABA and now window will be what? BAC. So what will happen? A will go. A will go. So A will become 1 now. Earlier it was 2. And C will be added. So C will become 1. Now if you see, these arrays again become equal. 1, 1, 1, 1, 1, 1. Hence this is an anagram. BAC is an anagram of ABC. So we will store the starting index. What is the starting index? B is the starting letter and B's index is 6. So 6 will be stored. And then we'll again shift to the new window. So new window is what? A, C, D. So B will get removed, D will be added. B will be 0 and D will become 1. So these are not equal again. Hence we have seen. Now what we have done, we have reached the end index. We have reached the end index and we have seen all the windows. And this is our final output. So what we are basically doing over here is, how we will think that it is sliding window. See, we have to find, we are given a specific pattern, right? We have to find whether this pattern is existing in the current string but rearranged. But it could be rearranged. Means the string we have to search will be of this much length only. So this is a fixed window. Window we need to find whether there is this window or not. Right? I hope you understood this dry run. How we are going. We have created 2 arrays. One is to store this pattern. And one is the window. This is the window which we are going. So let's see this in code. I hope you understood the approach. See, code is very simple. What we are doing is, first of all, we are finding out the size of these two, string and pattern. Now, for example, see, let's say this is an edge case in which we have a pattern of, let's say, 4 size. This is a pattern. And a string which is given to us is AB of 2 size. So we have to find whether anagram of this is there in the string or not. So obviously it could not be there, na? Because this has 4 letters and this is only 2 letters. So we just need to check whether length of pattern is greater than length of string. Then there will be no anagram. And then we are taking 2 vectors of 26 size. Initially they are 0, 0 because in these we are storing the count. na count of letters or count of each letter. So 26, this is a window, this is a window, and this is a pattern one. That is here, if you see, we have taken, this is a pattern and this is a window. Then we are finding for the first window. Just for the first window, we are just filling these. So when we were doing for this CBA, this was the first window na? So for this CBA, we were filling here in this window and this pattern here. So first of all, pattern also we here frequency we are adding, and that P of I, this will be P of I. For pattern we are just filling this array ABC, and for this also window we are filling this CBA first window. Now what we are doing is we are just first checking whether these two arrays are same. If these two arrays are same, then means this is the first window was one of the anagram. So here if both the vectors, so we can compare two vectors. When we compare two vectors, they will compare the size, they will compare whether two vectors have equal elements or not. Right? So here two vectors we are comparing, and if these two vectors are same right now, means this first window was our anagram. So starting index will be 0. So we will push in our answer vector, we'll push 0 index. That is first window is our anagram. After that, what we are doing is we will now go to the next windows. That is, we will start. So if this is CBA, EBA, BACD given to us. So first of all, we considered this window. Now we will have to, I will point here, and this window we will consider, this window. That means, this means that this S of I, this is S of I, this is your S string na? S of I will be added in your window, this will be added, and this C will be removed. This C will be removed. So how we will get this C? This C will be I minus this length. How much length is there? Pattern length. So if this I, if you do indexing 0, 1, 2, 3, 3 minus, I is currently at 3 index, 3 minus P length. So our pattern length was 3. So 3 minus 3, 0. S0. Means S0, this we have to eliminate from our current window. So what we are doing is, we are going and we are eliminating Si minus length, this one, from our current window. And window, we are adding what? We are adding current S of I. This minus a character we are doing, this will give us the index. It will be like this, a sky of this thing, this whole a sky of this, minus a sky of this A. So this will give us the index at which like over here, what index will be there for the letter. So here we are removing this from the window, and here we are adding this in the window, and then we are again checking whether the array vectors are same. If vectors are same, then I minus len p plus 1, this index will be our starting index of the window. So this will be a starting index. I minus length plus 1 we are doing because these are, this 1 will get less, so plus 1. Just dry run this once on this test case, you will understand how it's working. If you submit this, it will get accepted. So, oh my bad, over here I'll just remove this. And time complexity of this code, if you see time complexity, we are what we are doing is, we are going on the string, we are going at each letter on the string, and we are just checking we are just comparing the vectors also. So vector is of size 26 na? So that will be O of 26, and what we are doing, we are going to each letter in the string. So this will be O of n into 26. So 26 is constant, so it will be O of n. Time complexity will be O of n. Space complexity, we are taking these two vectors, and these two vectors are of constant space, that is O of 26. So space complexity will be constant, that is it will be O of 1. I hope you understood the approach and the problem. Let me know in the comments if you have any doubt, and if you found the video helpful, please like it, subscribe to my channel. I'll see you in the next video.